We'll use this simple example to explain present value. So let's say I give you the opportunity either to get $100 today or $110 in a year from now. Looking at this, initially you might think, oh, $110 is worth more than $100. So if I don't need the money right away, why wouldn't I wait a year to get that $110? And so I'll explain why that's not the case. We can't really compare these two values because this is a future value. This is $110 in a year, and there's many factors that affect kind of how we consider that value in the future as compared to the present value or the value today of that $110. So I'm not giving you $110 today. So you cannot say that this is equivalent to 100 and 110, if that makes sense. So we have to convert this into a present value, and there's a formula to do that. So the present value here we can see is calculated by FV, or the future value, over 1 plus I, the interest rate or the discount rate when we're talking about bonds, raised to the power of n, n being just the number of years. So in this case, if we're doing this example, we've established, okay, we need present value. We're given a future value, so let's input those values into our equation. So present value is equal to 110 over 1.10, so that's 1 plus, I'm here using actually a 10% interest rate, and I should have specified that at first, but I'm using a 10% interest rate, so it's going to be 1.10 raised to the nth power. So nth power in this case, is going to be 1. So what do I get from this? Our present value is going to be $100. So we can see just objectively, comparing today and comparing in a year, we're getting same value. So wouldn't it be better just to take it today if it's going to be on equal terms with comparable terms, the same amount of money? And let's say I give you another opportunity here. I give you the opportunity to invest that money. So let's say you're investing at the same rate of interest at 10%. So if you choose to invest that money, you're going to have that initial value, $100, times the rate of interest, so 1.10. And so you're going to see that in the end, if you choose to invest that money, you're going to earn from it. You're going to get $110, right? So in both of these cases, it's better just to take the present value, the $100 that I would offer you today, rather than to wait a year to gain or to get either a lesser amount or the same amount, right, of money. So when we're talking about kind of what makes this way, first thing we should mention is opportunity cost. So opportunity cost in economics meaning just what are you losing? What is the cost of the opportunity that was not taken? So if you choose not to invest that money, you're losing out. Similarly, we can look at this kind of in the sense that if you lost the opportunity, to spend that money right away on maybe something you wanted to buy. So that's an opportunity cost. We can factor that in as an opportunity cost as well. We can also consider inflation. So obviously, in a year from now, maybe the prices of goods are going to increase. And so that means that $100 in the future is not going to be the same as $100 today. Maybe I can buy more with that $100 today than I can in the future. Therefore, you're losing out again in this case too. And default risk is the last part here, just meaning that there's a risk that might mean that your money may not be paid back. So present value in that case is always the better scenario there. There are two variables that affect present value. In this case, so we have interest, and it's an inverse relationship between the present value and interest rate. So if interest rate increases, present value decreases. And time value of money, which is really just the value of payment, how that changes depending on when payment is received, which is what we've been talking about here, right? So future value is less than the present value. And that's exactly what is kind of written down here. As the period of deferral is increased, or the time that it takes to pay back money is increased, then there's going to be a decrease in that present value. So the final example here that I want to take is just the price of a bond. So in this scenario, we'll say that a bond is issued at $1,000 at an interest rate of 4%. And after 1 year, you decide to sell this bond, but the interest rate has increased to 5%. So how does this affect the price of the bond? We can calculate this just by taking the value of that bond, so $1,000 by the interest rate, so 1.05, and we find out that it ends up being $952.38, which is obviously less than that initial value, at $1,000. So what causes this decrease in value, you might ask? And really, when we look at this, we can find that the bond price is equivalent in a lot of ways to the present value. And this is just due to this intrinsic relationship between not only the bond, the price of the bond and interest, but conversely also the effective interest on present value. And so all of these things kind of tend to affect one another and create a very similar reaction in terms of bond price and present value. So we're going to see that it's exactly the same reaction. When interest rates go up, this creates a decrease in the price of a bond, which is a capital loss. And if the interest rate goes down, then it means there's an increase in the price of a bond, which is a capital gain. So a lot of these things are pretty similar in practice.